All right, Brandon Clayton here, the Algebra Guy. Today, our lesson is discussing finding circumference and area of a circle. So let's jump right into it. By the end of this video, you'll be able to find circumference and area of a circle, use the properties of circles, and find the area of irregular figures as well. So let's start with some basic properties of a circle. If you're looking at this circle here, let's identify some pieces. Now, if you're watching this lesson, you're probably already familiar with these pieces, but let's make sure we go over them anyway. From the center to the edge of the circle, we call that the radius. A line going all the way through the circle, through the center from edge to edge is called the diameter. So another way to think of the diameter is you just got two radiuses. Two radii is what I should say, 2 times r. Circumference is the perimeter of a circle. So unlike if we had a polygon, so if I had a polygon of some sort, let's say this was a rectangle or a square. If I wanted the perimeter, I'll add up all the sides. I'll call that perimeter. But if this one doesn't have sides, this is just a big circle. So instead of calling it perimeter, we call it circumference. And the formula for circumference is 2 pi r, while the formula for the area is pi r squared. Let's work some problems involving a circle. Let me get my circle tool out, see if I can draw some. That will help us out. All right, so a circular table has a diameter of 4 feet. So we got a diameter. Let's say that's the center right here. And we got a diameter of 4 feet. I need to change this color. There we go. And we're going to say that's 4 feet. What is the circumference? Well, we need to first remember the equation for circumference. So we read the problem. We know what we're looking for. We're looking for circumference. And we've identified circumference with the letter C, so we've done that. Now we need to set up an equation, and we're almost there because we have the formula for it. And formulas are always a good way to start problems like this: volume, perimeter, area, because it gives you the blueprint that you need in order to solve it. So how are we going to do this? We're just simply going to plug in what we got. So we're looking for circumference. We have 2 pi doesn't change. That's 3.14. And radius is what we need, and we know that radius is going to be, let me see if I can write it in here. So if my radius was here, it wouldn't be 4, but it would be half of 4, it'd be 2. So when I rewrite this, it's going to be 2 pi times 2, which is the same thing as 4 pi. And depending on how they ask the question, will determine whether or not how you use that pi. If they want a perfect answer, it'll just be 4 pi. But if they wanted the answer to the nearest, like say 10th, then you're going to have to multiply 3.1415, that long number, by 4 and round it to the tenths. I'm going to assume that they asked me to round it to the tenths just so you can see what that would look like. Get my calculator. That is not my right screen. All right, calculator, there we go. All right, so in this instance, we'll have 4. Let me see if I have a pi button. Yes, there it is. So I can do 4 times, and here's my pi, 3.14, and press equal, and you get this long number here. So I will round that, let's say they said to the tenths. So I would say that the circumference is approximately, because I'm rounding, let me put the approximate signs, 12, and I say to the tenth, so I'm going to look at the tenths place, look to the right. I see a 6. That's bigger than 5, so we're going to go up to 6. So that's 12.6. And the units we're using is feet, so 12.6 feet, and that's how you want to answer that. So either one of these would be correct depending on if they ask you for more information from the answer, or if they had answer choices that looked like yours. Find the diameter of a circle with a circumference of 4.71 meters. So what are they asking for? Diameter. So we got that piece. We read the problem. Let's let diameter represent D because that's what it usually represents. Got that. Let's see if we can set this up to translate this problem into an equation. Well, we're looking for circumference. So I'm going to again start with the circumference formula, 2 pi r. And what are we looking for? We're looking for D. Well, I don't have a D here. So let's use the other formula because 2 times R is the same thing as diameter. So there we go. So I can use this second one. And we know that the circumference this time is 47.1. So in place of the C, I'm going to put 47.1. I should want a different color. All right. And I know that we're looking for D. We're going to leave that there. So how am I going to find D? Well, I need to isolate D by itself. So I'm going to divide pi. So I'm going to divide by pi there. They didn't tell me how to round this, but I'm going to go ahead and round to the nearest, let's say hundreds this time. Oh, actually, let's say tenths. No, I say hundreds. Since they gave me in the tenths place, I think it's customary to go one more decimal place over when you're working the answer. So we'll go to the hundreds. So this leaves me with D equals 47.1 divided by pi. So 47.1 divided by, and here's my pi. Press equals, and there you go. So the hundreds place, wow, how interesting, because it's 4.99. So there's a hundreds place there. So my answer should be 14.99. Why? Because to the right of that hundreds place, I have a 2, which means it stays, the hundreds place is going to stay the same, which was a 9. So let me make sure I set it up. I solved it. Did I answer the question? Yes, it is. I answered what the diameter is. And then I make sure I put in the full sentence. Find the diameter. The only thing I'm missing here is the units. Please make sure you remember that. So this should be 14.99 centimeters. Centimeters. And I could have just abbreviated cm. But don't forget that to fully answer this question. All right, next let's move on to how to find the area of an irregular figure. So you could probably figure out what we're after here. Get it? Figure out irregular figure. How will we solve the area for this? So one of the things we can do is divide the irregular figure up into figures that are more familiar to us. Like by me drawing this line right here, I now see 2 rectangles, one on the top and one here on the side. So to find area, I'm going to do 4 times 12, which is 48. They didn't give me any units to work with, so I'm just going to leave it 48. And I want to use a color that pops out a little bit better. And right here, the width, if you will, is 2. What is this distance? Now, you're tempted maybe to say 10, but that's this whole thing. But if this whole thing is 10, this is 4, so the rest of this has to be 6, because 6 plus this other 4 will give me 10. So now I have this rectangle, 6 times 2, which is 12. My total area is going to add these both up together, 48 and 12, which is going to give me 60. So I'm going to say 60 units squared, since I don't know what they're measuring in, whether it be inches or centimeters or whatever. All right, what about this one? So same thing, I can divide this into 2 shapes that I'm familiar with. There's a rectangle that's 8 by 4, which is 32. And it looks like a triangle, so this is area of a triangle is 1/2 base times height. And that's 1/2, what's my base? What is this? This is a 5, and that's an 8, so this must be 3, because 3 and 5 gives me this whole thing. And what is this going to be? Well, this whole thing is 7. This is 4, so this must be 3. Isosceles triangle. So now I have what I need to set this up. Base and height are going to be 3 by 3. And remember, the base and height on the triangle are going to be perpendicular relationships. And as you can see, this is making a perpendicular or a 90-degree angle. And I usually won't go by visual because they usually tell you that, but I'm pretty sure they're assuming that you can see that that's a right triangle. 3 times 3 is 9. times 1/2 is 9 over 2. And so I got 32 plus 9, let's say plus, do it this way, plus 9 over 2. So what is that going to be? If I rewrote 9 over 2 as a mixed number, I should get 4 and 1/2. 4 times 2 is 8 plus 1 is 9. So what I'm really looking at is 32 plus 4 and 1/2. So it's going to be a half. 6 and 36. So 36 and 1/2 would be my total area for that region. All right, our last one here is involving this track. So a high school track is shaped like a rectangle with a semicircle at each end. The rectangle has a length of 105 meters. So from here to here, it is 105. Oh, I can't see that color that well. So this is 105 meters. And width is 68 meters. So this is 68 meters. What we want to know is the area enclosed by the track. So the area just of this track is going to be what? Well, how will we figure that out? Let's kind of sketch up something. We read the problem. We want to know the area of the track. So we're looking for A, the area of our track. And we're going to say area of the rectangle minus area. No, I don't want to minus that. I just want area of the rectangle. Area of the track. Let me read it again. The area enclosed by the track. Oh, yes. So I want the area of the track. So I need to first look at this track to get some dimensions before I can figure out what this is. So I know that this piece right here, from here to here, is 105. But how much is this piece and this piece? So I can figure out the length and the height. So I got the height of 68. So let's start with this track. First of all, let's break this into pieces. We got a track that's a rectangle. So if we look at it, this yellow part here, there's a rectangle. So what's the area of this rectangle? Well, that's going to be 105. Erase that. It's going to be 105 times this height, which is 68. And I'm going to put that in my calculator. 105 times 68, 7140. And meters is what we're looking at. So this area right here is 7140 meters. So, but how much are these pieces on the outside? So these little edges here. Well, these are two semicircles. If we put those together mentally, we'll know it's one whole circle. And to find the area of a circle, is area equals pi r squared. What do we have to find area from this problem? Well, we know if you look at carefully, you'll realize that they gave us the diameter of 68. That goes all the way across down the middle. So half of that would be my radius. Make sure we're looking for area. Yeah. So pi and my radius will be half. So from here up, or there down, it'd be half. So that would be 34 squared. And let's estimate that because we're looking at the hundreds place. Actually, let's keep it in this form because I always like to keep it like this until we get to the last part of the problem. Because if you start rounding too early, your answer is going to be off. So let's go ahead and do this one. 34 squared times 34 is 1156. So this is going to equal 1156 pi. All right, so now we got the area of this whole thing. So that's not everything. but that tells us what most of this area is. Find the area enclosed by the track. No, I think that is area enclosed by the track. So yeah, that is everything. So this whole track, we got 7140 and 1156. So let me go ahead and convert this into a decimal. So this is going to be times pi. And there we go. So I'm going to take this whole number, just the way it is, and I'm going to add it, because that's just the area of the circles. I'm going to add it to the rectangle area here in the middle, 7140. And then I'm going to round to my nearest hundreds because I'm done. So that gives me 10771.68, and I believe that's meters. Yep. So we rounded to the nearest hundreds, and we got 10,771.68. All right, and that does it for us today. Finding circumference and area of a circle. We use the properties of circles, and we found the area of irregular figures. Thanks for tuning in. My name is Brandon Clayton, the Algebra Guy, and I will see you next time, next lesson.